Well, we're finishing up this chapter section 4-2, solving quadratic equations by graphing. And we have a real world problem here that we're going to take a look at. We're going to solve it by using a calculator. And as part of that, we're going to use one of the calc features that we find on our calculator that will help us to estimate a zero or a solution. So let's read what we have here, and then we're going to jump to the calculator. So we got a package of supplies that's being tossed from a helicopter at an altitude of 400 feet, and we're asked to determine how long it would take to reach the ground if the height was modeled by a function equation h of t equals negative 16t squared, t as being time, plus 48t plus 400. And obviously that 400 is the 400 feet that we're dropping this package of relief supplies to some poor souls that need some type of emergency relief from 400 feet. Well, let's move over to the calculator and see if we can determine how long it's going to take for this package to reach the ground based on the model that we have here. Okay, so we're going to graph this equation, negative 16t squared plus 48t plus 400. Let's see, I probably want to go in here and make some initial window adjustments. I may have to change it again. I'm going to go back to my standard window to begin with. Let's see, 10. All right, and let's go over here to y equal. We're going to clear what we got in here. And I'm going to substitute x for t in this. So I got negative 16 x squared plus 48x plus 400. All right, well, let's first see what we got here on the graph. Okay, kind of weird looking. I'm going to go in here to zoom. Now again, I'm going to go zoom fit or zoom 0. All right, that's a little bit better. Now, you can see here that I've got zeros both on the negative side of the x-axis and the positive side, but time cannot be negative. So the only thing I'm going to concern myself with is this zero over here on the right-hand side. We really want to just demonstrate how we can use this calc feature. So I'm going to go second trace or calc, and this time I'm going to choose option 2 or 0. And I can see my cursor's up there at the top, so I'm just going to move it along, and you can see it's moving along the axis, and I want to get it just above the x-axis. Okay, that looks just above the left axis. It says left bound, and I'm going to hit enter. And now I'm going to move it to the right bound just below the x-axis, and so that looks to be below the x-axis. I'm going to hit enter. And it says, hey, do you want me to guess? And I say, well, why not? Let's just guess. And I can see here that when x is 6.72, or 6.7, let's say, y is equal to 0. So when y is 0, we've hit the ground. And by the model that we had in this equation up here, it gives us what it is up here at the top, it would take 6.7 seconds for this relief package to hit the ground when it is dropped or tossed from a helicopter at 400 feet. All right, so we graphed it, we used the calc feature, and Shazam, with the calc feature and picking the option to find the 0, we estimate the left bound, the right bound. It asks us to guess, why not? And there we go, 6.7 seconds. Pretty cool, huh?